Our autonomic nervous system allows our bodies to make acute changes in order to respond to stressors such as exercise. There are two branches of the autonomic nervous system, the parasympathetic branch and the sympathetic branch. You may know the sympathetic nervous system as our fight or flight mode, and the parasympathetic nervous system as our rest and digest mode. These two systems work together and are never fully turned off. Imagine you're in a car and you want to go faster. What do? First, you have to make sure your foot is off the brake pedal. Second, you need to step on the gas. When you exercise, your brake pedal is the parasympathetic nervous system, and your sympathetic nervous system is your gas. So when you let off the brakes, or decrease parasympathetic tone, your heart rate begins to rise. When you push on the gas pedal, you increase your sympathetic activity and speed up your heart rate. The autonomic nervous system is a central mechanism that controls the heart rate and blood pressure response to exercise. It is referred to as central command, and the command signals that are sent out during exercise generate from a region of the brainstem called the medulla oblongata. The signal then travels via sympathetic nerves to a region of the heart called the sinoatrial node, which tells the heart to beat faster and more forcefully. Our central command center is so prepared to act that just thinking about exercise can cause our heart to beat a little faster. In addition to central command, there are neuroreflexes that are generated in the periphery of our body to help regulate the rise of heart rate and blood pressure with a bout of exercise. The first is the arterial baroreflex. The baroreceptor sense stretch caused by changes in our blood pressure. These mechanoreceptors are located at the carotid sinus, which sits just above the bifurcation of the common carotid artery. These small receptors help tightly maintain our blood pressure. To keep blood pressure at the higher level needed to exercise, our body sets a new operating point to maintain adequate oxygenation. When blood pressure falls, these receptors are not stretched, and thus there is an increase in sympathetic nervous system to increase heart rate and maintain blood pressure. Compared to central command, that is referred to as a feed-forward mechanism, the arterial baroreflex is a feedback mechanism. The next peripheral reflex is the exercise pressor reflex. It was discovered by two scientists, Allam and Smirk, in 1937. They found that there are two types of receptors located within the skeletal muscle, the mechanoreceptors and the metaboreceptors. Mechanoreceptors respond to your muscle contracting during exercise. The receptors, when stimulated, send action potentials via group 3 sensory fibers to the brain. The metaboreceptors are responsive to chemicals that accumulate in your blood during exercise, such as lactic acid. These receptors send action potentials to the brain via group 4 sensory fibers. These peripheral signals cause an increase in sympathetic nervous system activity, which will elicit increases in blood pressure to make sure the active muscles get delivered enough oxygen and nutrients. Our autonomic nervous system prepares us to do exciting things like run a marathon or climb a mountain. Not only does our central nervous system command the proper response to do these activities, but our body has many control points such as the baroreflex and exercise pressor reflex, doing all the hard work so we can focus on the fun things.